All right, welcome back everyone. This is Noah, and in this video we're going to go through the solutions for the now you try problems where we're given a quadratic function in standard form. We want to convert it to vertex form and then find the key points, the vertex, the y-intercept's mirror point, the x-intercepts, and two additional points to then graph the function. The first example that we're going to look at is f of x equals x squared minus 18x minus 12. And we're going to start this off by completing the square in order to put it into vertex form. This first one's nice because the leading coefficient is 1, so I don't have to worry about an additional factoring step there, or brackets, or anything else that gets more messy than this. So I start by saying x minus 9. I take half of that minus 18 to get the minus 9 in there, and we square this. By consequence, this adds 81 to our problem. So we need to also subtract 81 here to keep everything in balance, and then bring down the minus 12. Go ahead and add those together. We'll get x minus 9 squared, and then this is minus 93. Cool. The vertex then is going to be the point 9 comma negative 93. That's a big number there, so I really want to be careful in how we set our scale. We'll get to that in a second. Let's go ahead and note that the y-intercept is the point 0 comma negative 12, and then its mirror point is going to be 18 comma negative 12, right? The x value is twice that of the vertex. The x-intercepts, I'll set 0 equal to x minus 9 quantity squared minus 93. You can add the 93 to the other side. 93 equals x minus 9 quantity squared. I'll take my square root of both sides, not forgetting the plus or minus when I do so. So we get the plus or minus square root of 93 equals x minus 9. We can add the 9 to both sides here and get 9 plus or minus the square root of 93 equals x. So the x-intercepts are the points 9 minus square root of 93 comma 0 and 9 plus the square root of 93 comma 0. Whew. All right, let's start graphing this. Y-intercept is negative, it's upward facing, the vertex is negative, the vertex is out to the right at positive 9. So I'm going to draw my y-axis to the left more. And I want plenty of space. Negative 93. If I go by 3s, I would need 31. And that's still just so big. What if I go by 6s? So we can put the x-axis really high up here. And we want to go, we want 18 all the way across here. So if I do, that's 6, 12, and 18 here. 18 for that mirror point, right? And then if I'm going by 6s, then this would be negative 12, negative 24, negative 36, negative 48, negative 60, negative 72, negative 84, negative 96, and that's good enough. That's down far enough to that minus 93. Minus 93 is, this is, by 6s, this is negative 90, so negative 93 is right in between there. The y-intercept, though, is at 0, negative 12. I can draw that in. And then the 18, negative 12 is across the axis of symmetry. 18 comma negative 12 here. So 0 comma negative 12. And then 9 is right there halfway between 6 and 12. Come down to negative 93. 9 comma negative 93. So there's quite the challenge just in getting our scales set up and finding these points. So take your time, make sure you've got those correct. And for the x-intercepts, I think I'm just going to find 2 other points. Let's like plug in maybe 2. If you plugged in a different point, that's fine. I'm just plugging in 2. I want to get something like in here just to kind of help me get the shape of my graph. I might add some more points as well. Let's see. It's going to be 2 minus 9 is negative 7 squared minus 93. It's 49 minus 93. 50 to 90 is 43, 4. Negative 44. 2, negative 44. Like there. And then I can mirror this across 9. So 3.5 grid lines to here. And that is at 16 comma negative 44. And this was 2 comma negative 44. Nice. All right, let's go ahead and draw in the parabola. We can kind of get, you see this line here between these 2 points is helping us quite a bit. This big graph. Get that all connected up. And this should just continue shooting up and just getting a little bit more vertical as we go. Same thing with this one on the left. And so we can see those x-intercepts now. This first one here is going to be at 9 minus the square root of 93 comma 0. And then the second one out here is at 9 plus the square root of 93 comma 0. Go ahead and sign off. Y equals f of x for the signature on this one, labeling the graph. And we're going to call it good. Let's move on to the next one. Let's see what kind of trouble we get in here. We have g of x equals 4x squared plus 40x plus 95. Go ahead and just focus in on those first 2 terms, factoring out the 4 to start. So we get 4 bracket x squared plus 10x. And then the plus 95 we've left alone. That's outside of these brackets now. All right, I'll give myself a little room. I'm going to go 4 bracket parentheses x plus half of 10 is 5, quantity squared. But by consequence, this adds 25 in here. So we need to subtract 25 as well to keep everything in balance, bringing that minus 25 down. That is inside of those brackets, super important. Bring down the plus 95. This one's not going to be so bad. This is going to be an easier problem, I believe. So I'm going to distribute the 4 across. 4 times x plus 5 squared, and then the 4 times minus 25 is minus 100. And then I'll have that plus 95 still. I don't know, I was a little too hopeful. I was hoping that I'd have a perfect square there, but it's not going to be. We're going to have 4 times x plus 5, quantity squared, minus 5. So that's fine. My vertex is going to be negative 5, negative 5. It's upward facing. It's stretched pretty thin there with that 4. Be paying attention to that. From the top, I can see, oh, that's huge. Y-intercept is 95, 0, 95. So yeah, that's up there. So we've got a whole 100 to go between the y-intercept and the vertex. So let's get this figured out here. The mirror is going to be at negative 10, 95. So So I'm going to put my y-axis out to the right. And then we want to, I don't know, if I need 100, let's do that in like 20s. So if each one is worth 5. That'll work nice because we have multiples of 5 for our y values. Then this would be 5 times 4 is negative 20, then negative 40, negative 60, 80, negative 100. Oh shoot, the y-intercept's at 95, not negative 95. Okay, that's actually not so bad to fix. I have to erase these numbers here. But I'm just going to move the x-axis down. So the x-axis is going to now be down here. Cool. So this is 20, 40, 60, 80, and 100. These are going by 5s. So 95, 095 is right here. Let's see, do I want to do anything with my x scale? I want to leave these by 1. So 1, 2, 3, 4, 5, there's negative 5. Negative 4, negative 8. That's good. So then negative 5 is going to be right here. This is negative 20. This is negative 5, negative 5. And then if I go up, finding my axis of symmetry, then I can take the y-intercept. Its mirror is going to be at negative 10. No, that's not far enough. There we go. So this is the point negative 10 comma 95. And this was 0 comma 95. I've got the y-axis, x-axis. Let's put that number over there. All right. I think we're getting somewhere. So let's get the x-intercepts. If I go 0 equals 4 times x plus 5 squared minus 5. I'll add the 5 to the other side. 5 equals 4 times x plus 5 squared. Divide the 4 over, so 5 fourths equals x plus 5 squared. There is one nice thing about this. When I take the square root of both sides, don't forget the plus and minus, I will get plus or minus the square root of 5, and then I can actually take the square root of the 4 is 2 in the denominator now. And so that'll equal x plus 5 when the square root and the square cancel. I will subtract 5 from both sides. So that I get negative 5 plus or minus square root of 5 over 2 equals x. So the x-intercepts are the points negative 5 minus the square root of 5 over 2, comma 0, and negative 5 plus the square root of 5 over 2, comma 0. All right, but those aren't going to be super helpful for this. I think if we plug in like negative 4, right, we'll be pretty close to that x-axis. So let's try that. Let's do g of negative 4, see what we get here. So it's going to be 4 times negative 4 plus 5 is 1 squared minus 5. And I'm just plugging that negative 4 into that vertex form there. And so this is going to be 4 times 1 minus 5 is negative 1. Cool. It's actually really close there, right? It's right there. And then this is going to be symmetrical. We're also going to have this point negative 6, negative 1 right here. And let's do a little bit more. Let's plug in like a negative 2 so that we can fill in something in this space. G of negative 2, we're going to get 4 times negative 2 plus 5 is a 3 squared and then minus 5. So it'd be 4 times 9. And we need to subtract 5. 4 times 9 is 36 minus 5 is 31. So 31 is going to be like right in here. Negative 2 comma 31. And then the symmetry line is here, so I'm going to fold that over here. So this is at negative 8 comma 31. Cool. Gap in here, so we could add another point. I think I'm going to be able to pull this off though. So I'm going to draw a parabola through these points first. And this is just getting more and more vertical. It's got to come through that y-intercept, come down like that, something like that. Down, pretty straight line, but slightly curving in, curving more and more, and then by the time we get to the bottom, it's curving nice and fast there. We'll zoom out a bit. Arrows at the end of my parabola to indicate it continues going. Label it y equals g of x. Whew, and give myself a little pat on the back here for persevering through these nice, long, tedious problems, putting all of this together. All right, everyone. Thank you so much for watching. I hope that this was nice and explanatory for you. Let me know if you have any questions via email. Otherwise, have a great day, and I will see you next class. Take care now.